everyone, welcome to episode of Learning Mathematics. Today, we're featuring a video assignment of SMG3013 Geometry. So, for this assignment, we were asked to pick a structure or building around UPSI that meets the elements learned in class. We decided to make a study of an academic block signboard in Block 1 of the Faculty of Science and Mathematics. So, let's go. Now, I'm standing in front of Faculty of Science and Mathematics. The thing about this building, it was named the Faculty of Science and Technology before it was named as the Faculty of Science and Mathematics in 2010. So, let's move on to the geometric structure, which is the signboard. So, beside me, this is the Block 1 signboard. Look at the bright blue color and its shape. Beautiful, isn't it? As you can see, there are many unique geometrical shapes and patterns engraved on it. There are rectangles, polygons, trapezoid, and circles. Look at how it fits within a strategic location. It helps people in recognizing it even from far.
This signboard has 4 sides, and the shape of this signboard is a rectangle. As we know, a rectangle is a parallelogram in which both pairs of the opposite sides are parallel. Other than that, all the angles of a rectangle is a right angle. This means that all the corners of the signboard is 90 degrees in measure. This shape is a rectangle where the opposite sides are parallel and equal. It is a three-dimensional shape having 6 faces, where all the face, top, bottom, and lateral faces of the prism are rectangles such that all the pairs of the opposite faces are congruent. The next shape is trapezoid. It is a quadrilateral with exactly 2 parallel sides known as its bases, and it also classified as an isosceles trapezoid where the 2 legs are congruent. The next shape is pentagon. It has 5 sides and is known as irregular pentagon. A pentagon also has 2 distinct pairs of congruent sides. The next shape is hexagon. Hexagon has 6 sides and known as irregular hexagon. It has 3 distinct pairs of congruent sides. Next, rhombus. It is a parallelogram with 2 congruent adjacent sides, and it also a quadrilateral because it has 4 sides with equal in measure. Next, kite. It is a quadrilateral with 2 distinct pairs of congruent adjacent sides. Next, circle. Circle is a 2-dimensional geometric shape that consists all points in a plane of a fixed distance.
Now, we're going to move to 2.2, which is the geometrical concepts. The signboard has a trapezoid shape with length of bases B1 and B2 and altitude of length h. The area of the trapezoid can be calculated by this formula. For the measurement of the trapezoid, the length of base 1, B1, is equals to 57.1 cm, and the length of base 2, B2, is equals to 143.5 cm, and the length of altitude, h, is equals to 82 cm. We will substitute all of this measurement into the formula, and then we will get 8,224.6 cm squared. The signboard also has an irregular pentagon that has 5 sides. The pentagon has 2 distinct pairs of congruent sides, which is A and B. The perimeter of the pentagon can be calculated by adding the 2 distinct pairs of congruent sides A and B and one last side, which is C. The perimeter is given by P equals to 2A plus 2B plus C. All of the measurement will be substituted into the formula and we'll get 65.5 cm. We can also calculate the area of a pentagon by splitting the pentagon into 2 equal parts so it forms 2 equal trapezoids. Therefore, The area of the pentagon can be calculated, which is given by this formula. The length of bases B1 and B2 is equals to 30 and 15.5 centimeters, and the length of altitude H is equals to 22.4 centimeters. When we substitute the measurements into the formula, we will get 638.4 centimeters squared. The signboard also has a motif that's a kite. It has two distinct pairs of congruent adjacent sides. The perimeter of the kite is given by P equals to 2A plus 2B. The A and B is equals to two distinct pairs of congruent adjacent sides. When we substitute these measurements into the formula, we will get 22.4 centimeters. The signboard has a motif that's an irregular hexagon. This hexagon has three distinct pairs of congruent sides. The perimeter of the hexagon can be calculated by adding all the distinct pairs of congruent sides. Perimeter is given by P equals to 2A plus 2B plus 2C. As for the measurement of the hexagon, A is equals to 1.8 cm, B is equals to 5.8 cm, C is equals to 6.5 cm. When we substitute these measurements into the formula, we will get 28.2 cm. The signboard itself is a rectangular prism, which is also known as a cuboid. First thing first, we will have to calculate the perimeter of the base, the front, and the left faces. And then we will substitute these calculations into the formula of the total perimeter of this prism. We can now find the lateral area of this prism. Now we can find the total area by adding the lateral area and the area of two bases. Since this signboard is a rectangular prism, we can definitely find its volume. As for the measurement for the cuboid, the base face has the length of 15.5 cm and the width of 81 cm, where the front face has the length of 200.8 cm and 81 cm of width. The left face, it has 200.8 cm length and width is 15.5 cm. The altitude of this cuboid is equals to 200.8 cm and the length of this cuboid is 81 cm, where the width to 15.5 cm. By substituting the measurements into the formula of each face perimeter, we will get the perimeter of the base, which is equals to 193 cm. The perimeter of the front, which is equals to 563.6 cm, and the perimeter of the left face, which is equals to 432.6 cm. All of these calculations will be substituted into the formula of the total perimeter of this prism, and we will get 2378.4 cm. Now that we have the calculation of the base perimeter and the altitude h, we can find the lateral area, and we will get 38,754.4 cm squared. As for the base area, we will substitute the measurement of length of base and width of base into the base area formula, and then we will get 1,255.5 cm squared. We can find the total area by substituting this calculation into the formula of the total area, and then we will get 41,265.4 cm squared. We can find the volume of this rectangular prism or this cuboid. We will substitute the measurement of this length, width, and altitude into the formula of the volume, and we will get 252,104.4 centimeter cubed.
Signboards are essential to visual communication because they combine our function to communicate ideas beyond words. These signs frequently feature originalities of motif and pattern which heighten their visual appeal. The basic operation of orientation, dilation, reflection, and translation are among the basic transformations in geometry that change the position, size, or orientation of geometric figures. Firstly, I would like to explain about the concept of transformation that exists in the motif of academic block signboard. Deletion. Deletion can enlarge or decrease motif, aiding visual complexity and interest to a line. Deletion is essentially the study of a motif's change in size while retaining its original shape. In this case, the motif on the symbol is hexagon. The following show the geometry motif in the form of hexagon shape, which has the concept of deletion. The amount of enlargement or reduction is determined by a scale factor that characterizes this transformation. Applying this idea to the flower motif on a symbol shows a situation in which the bloom changes its rotation. Besides, I would like to explain about the concept of transformation that exists in the pattern of academic blocks and lot. Reflection is a transformational process at this symbol. Star and pentagon shape is reflecting itself. In this transformation, the item is split across the line, forming a symmetrical duplicate with equivalent points that remain equally distant from the mirror line but appear in opposite directions. That's all for me. Thank you.
To summarize what has been discussed so far, the signboard of the Faculty of Science and Mathematics is the signboard to guide the visitor, staff, lecturer, and student to the correct block. As we can see, the signboard has unique pattern and many geometrical shapes based on Islamic culture in the Middle East. Our team measured all the geometrical shapes on the signboard using ruler and measuring tape to ensure accurate dimension and measurement. We are also calculate of the perimeter, lecturer area, and volume. Lastly, we also study about the transformation of motif and pattern, discussing concepts such as dilation, rotation, and reflection to the signboard's geometric element. In conclusion, the task has provided valuable insight into the practical application of geometry in our daily life. The structure, design, and geometry shape of the signboard make it more prominent and visually striking.
That's all from us. Thank you.